Hi everyone, I'm Rob Walker from Autodesk in the UK, and today I will be presenting cross-product workflows for advanced manufacturing.
Now I'll not go through this, but just as a reminder, this is the class summary, highlighting what you will expect to see today. Hopefully this seems familiar and that you are attending the session you intended to do so. Now for today's presentation, we'll begin with a brief introduction including looking at the current product portfolio. We will then look at the path we are taking to support our customers and introducing Fusion 360. We'll move on to a more detailed look at Fusion 360, followed by a series of workflows which show how Fusion 360 can be used with PowerMill, PowerShape, PowerInspect and FeatureCAM. We'll then finish with a session summary and some time for questions at the end. So let's begin. We'll start with a little bit about me. I am an engineer by education with a bachelor's degree in aerospace engineering and a master's in product design and management, both from the University of Liverpool. I began my career with Delcam as an applications engineer, initially starting in the UK department, where I trained and supported UK customers before moving to an international role where I assisted the global network of subsidiaries and resellers in both pre- and post-sales activities. Following the acquisition of Delcam by Autodesk in 2014, I moved to technical marketing and I am now into my 17th year of service. I am now a senior technical marketing manager, and myself and my team are responsible for helping customers understand how they can achieve their manufacturing goals using the advanced manufacturing solutions that Autodesk offers. I wanted to start this presentation by looking at why customers come to Autodesk for advanced manufacturing software. Well, Autodesk brings together established and proven manufacturing technology through what we call the Make portfolio. These products provide you with the advanced manufacturing solutions you require for solving complex challenges. This technology is backed by our global team of direct and indirect channels, providing the expertise needed to help integrate, optimize, and automate your manufacturing. So clearly we have a lot of technology in our portfolio, but for this particular presentation I want to focus on some specific Autodesk products, those being PowerMill, FeatureCAM, PowerShape, and PowerInspect. Now for some of you, you may have one of these products, some of you might have more, or even all of them. But for the benefits of those that don't, I wanted to give a quick overview of each so that we're all on a level with regards to the knowledge of each product's intended function. And we'll begin with PowerMill. Now PowerMill is our expert high-speed and 5-axis CAM software for manufacturers of molds, dies, and highly complex components who want to achieve the maximum quality, control and precision, yet with increased flexibility, efficiency and throughput from their 3- and 5-axis machines. PowerMill's high-speed strategies are designed to achieve exceptional metal removal rates which help avoid full-width cuts, maintain constant chip load and prolong cutting tool life, extracting the maximum performance from your CNC machine and cutting tools. Stock models help roughing and rest roughing toolpaths efficiently remove material without excessive air cutting, with rest finishing strategies which minimize the need for post-machining rework or polishing. Powerful toolpath editing tools allow programs to be optimized to meet the specific needs of the programmer or part, without the need for wasteful complete recalculation. It can be used to program 2.5-axis and 3-axis milling machines for prismatic part machining and advanced 3-axis surfacing. It supports 3+2 machining with the ability to dynamically reorientate your CNC machine's rotary axes to minimize tool lengths and reduce the number of machining setups and fixtures required. It also provides tools specifically aimed at getting the best from your simultaneous 5-axis CNC machines, offering programmers tools to fully control their CNC machine motion to machine parts more efficiently with fewer operations, with integrated machine simulation, toolpath collision checking and avoidance to avoid the need for costly trial and error prototyping. PowerMill supports mill turn machines combining 3- and 5-axis and turning strategies into a single CAM environment. It has dedicated tools for the offline programming of industrial robots, avoiding axis singularities and other robot-specific issues with the ability to program up to 18 external axes for complex work cells and output native robot G-code for added reliability and peace of mind. It can be customized and automated, where standardized best practices can be saved and shared, and repetitive tasks automated for huge productivity gains. It has dedicated specialist roughing and finishing strategies for blade, blisk and impeller machining and port machining, and has the ability to perform on-machine probing for in-process checking of part surfaces. Next we have FeatureCAM. Now FeatureCAM is a comprehensive feature-based automated CAM software for CNC programming. It has a different approach to conventional programming in that it breaks down parts into features and machines those features with one or more associative operations. It is highly automated, with interactive and automatic feature recognition automatically generating NC code based on a part's features. Now, because of the automation, it quickly produces consistent, repeatable results and is ideal for speeding up the effectiveness of less experienced programmers. Built-in intelligence can be used and customized, allowing the lessons learned across teams to be captured and standardized as CAM programmers' best practices within an organization. Its comprehensive capabilities means it supports a wide variety of machine types, including 2-axis and 3-axis milling machines for fast prismatic part machining and advanced 3-axis surfacing. It can also be translated to 3+2 index milling for milling machines and turn mill lathes. It can be used for multi-axis milling, including 4-axis wrapping to apply 2D toolpaths to cylindrical faces, and simultaneous 5-axis machining with the ability to detect collisions during simulation and apply corrective avoidance tilting during calculation. FeatureCAM can be used for turning, to produce round parts on CNC lathes with advanced turning and mill turn capabilities to address multi-turret, multi-spindle and B-axis multitasking machines and ultra-fast Swiss turning machines with PartMaker. And it can be used to program simple 2D and multi-axis wire EDM machines, and has the ability to perform on-machine probing for part setup and in-process checking. Next we have PowerShape. Now PowerShape is CAD software with surface, solid and mesh modeling tools designed for complex parts, electrode design and modeling for manufacture. Third-party CAD data can be imported into PowerShape from virtually any commercial CAD format or neutral formats such as IGES or STEP. Powerful analysis tools can then be used to identify and isolate potential manufacturing issues. Whole model edits with any missing or low-quality data can be quickly made with the ability to find and automatically repair faults, which are categorized by type and severity using the Solid Doctor wizard or editor. PowerShape can be used to refine geometry, to optimize machining processes, letting you create the exact geometry you need to get the best performance from your CNC machines. Parts can be scaled to compensate for shrinkage, or material offsets can be added to cast or additive part surfaces for finish machining later, and holes can be covered up for better machining performance. Flexible surface modeling tools can be used to create precise surfaces optimized for manufacturing, with the ability to create reference surfaces for a safe, reliable 5-axis machine toolpaths. Surfaces and solids can be created or re-engineered using mesh models derived from direct scanning or point data when reverse engineering parts. And finally, we have PowerInspect. PowerInspect is a hardware-independent metrology solution for all of your inspection, verification, measuring and reporting needs. Being hardware-independent means it is a universal measuring solution which can be used for manual or CNC coordinate measuring machines or CMMs, laser and camera devices such as scanners and trackers, and inspection arms. It can also be used with CNC machine tool probes, allowing the implementation of automated part setup, sometimes referred to as adaptive fixturing. PowerInspect can be used for datum calculation and combined with advanced best fitting that updates CNC machine tool coordinate systems and reduce part setup times. And because it can be used with CNC machine tool probes, it can be used for on-machine verification, allowing the creation of in-cycle probing to measure freeform surfaces and geometric features. PowerInspect is also used for clay milling, utilizing PowerMill in the background to generate automatic toolpaths from user templates to perform model milling on a CMM. Now, as we continue to grow the make business using this powerful combination of technology and distribution, it's important that we acknowledge the existing challenges broadly with technology in the design and manufacturing industry today. And so I wanted to look at the path forward. Now imagine you have a single designer or engineer in an R&D department or small business. Engineers like this have to wear multiple hats. In the past, that's meant multiple products. Now Fusion 360 flexes your needs. Fusion 360's flexible and intuitive platform can be configured to your team's size, use case, and workflow, so you get access to the enterprise-grade features and services you need and only pay for what you use. Fusion 360 also intelligently powers your decision-making. Generative design identifies thousands of solutions to the problem you define, simulates their performance, and optimizes for your constraints and manufacturing capabilities, so you can get the more high-performing, cost-effective, and sustainable designs that you couldn't have reached on your own faster. And Fusion 360 creates a dynamic network. The integrated platform connects your entire product development and manufacturing ecosystem with a central cloud-based model, eliminating the friction between people, activities, and machines, so your teams can collaborate seamlessly and spend more time on innovation than iteration. And Fusion 360 can move your business and industry forward. Fusion 360 invests in the future of product development and manufacturing, catalyzing innovation across disciplines, so your team has the tools to automate mundane tasks, the agility and connectivity to manage supply networks, and access to the latest manufacturing technologies to realize previously impossible outcomes. Fusion 360 reimagines the product development process and provides people with access to their data in a connected, flexible, and seamless way. We're bringing together technology that's previously been delivered separately. We're investing rapidly in intelligent means of automation. We've architected the software for collaboration as a natural part of design and manufacturing, and we're providing extensibility to third parties using an established technology platform through Autodesk Forge. This positions you to work in new ways in an industry where no other software vendor has this type of planned-out strategic approach. We want to provide this technology to you so you can begin to take advantage of this next-generation workflows available in Fusion 360. So hopefully this highlights why we have developed Fusion 360, but I know some of you might not be aware of what Fusion 360 is, so let's look at that in a bit more detail. Well, Fusion 360 brings together technologies that have previously been separate. By building Fusion 360 in this way, we are able to differentiate in the market in three main ways. With an integrated platform that makes it easy to connect all phases of your product development process. You can view data from a single source and easily collaborate with both internal and external stakeholders, and you can access your data and technology across devices from a single, affordable offering. Being integrated means being able to go from design to machining faster, with design changes which can update toolpaths associatively made from Fusion 360 or with other CAD tools using ANYCAD. A collaborative environment makes it easier to communicate faster, speeding up the communication between designers, engineers, and machine operators. In terms of accessibility, Fusion 360 can be accessed across devices, whether it's a browser, mobile, PC, or Mac. For manufacturing, it comes with a library of open-source, free standard post-processors to post G-code to a wide range of machines. And there is an abundance of free training courses and videos to help you learn Fusion 360 more easily. And there are many other benefits. Your data can be accessed from anywhere, minimizing the need to carry large hardware or memory sticks with you. Fusion 360 is licensed to the individual rather than the PC or Mac. This allows you to go on any computer in the world with Fusion 360 and get access to your data. The cloud also brings cloud computation, removing the need for state-of-the-art hardware, minimizing this capital cost from the user, with cloud storage meaning you won't need to purchase extra hard drives as you'll never run out of space again. And one of the most powerful aspects of the cloud is collaboration. The cloud lets you communicate on designs without leaving the design space, getting your colleagues' opinions, good or bad, on your products. Lastly, there's data consolidation. All data stored in one place, accessed from one platform. The drawing, the design, the manufacturing data, the simulation results, and so on. So let's have a look at the Fusion 360 workspaces in a little more detail. First, we have the design space. Designing a product can be split across several workspaces, including the model workspace for solid and surfaces creation, the mesh workspace for handling STL triangulated data, and even a sheet metal workspace to turn flat geometry into fully bended 3D sheet metal components. Having multiple different modeling techniques means industrial designers, product designers, and engineers are in the same environment. Then we have generative design. In generative design, you start with the problem definition. You define, preserve, and obstacle areas where geometry can and can't go, the load cases, the manufacturing method, and generative design takes over, using the problem to generate or grow a design that meets the needs of the problem. And not just one design, but many different designs from which to choose from. There's also a simulation workspace, which allows you to analyze your design in many different thermal and mechanical studies. It can help you determine how the part will behave during its operating life to understand whether the design is fit for purpose, and can save time as you experiment with virtual design variations or adapt to changing design requirements, providing design verification which helps avoid costly physical prototyping and destructive testing requirements. And finally, we have the manufacturing environment, which allows you to turn your design into reality across a variety of techniques, including additive and subtractive processes such as milling, turning, and turn mill, and profiling. Fusion 360 has multi-core computation, which reduces your programming time by allowing you to continue working while toolpaths are being calculated. It also has stock simulation to provide toolpath verification, and the wide array of free and customizable post-processors to manufacture your parts. So why am I telling you this? Well, for a while now, Autodesk has provided advanced manufacturing product subscribers with access to the Fusion 360 platform. This culminated late last year in the repackaging of FeatureCAM under the Fusion 360 brand. In a continuation of this, and you may have already heard this or been contacted about it, so I won't go into the details, but we have now decided to repackage PowerMill, PowerShape, and PowerInspect under the Fusion 360 brand too. The aim of this is to create more awareness of Fusion 360, the complementary benefits it brings to our customers, including intelligent automation, and where relevant, seed a natural path to Fusion 360. These new subscriptions enable you to continue using PowerMill, PowerShape, or PowerInspect as you rely on them today, but they also provide access to the technology that will shape your future work through Fusion 360 and consumption services. And included in your single-user subscription, you now have the latest manufacturing developments through the Fusion 360 manufacturing extension in addition to Fusion 360 itself. With all that understood, let's take a look at some example workflows. We'll begin with a Fusion 360 with PowerMill workflow. Now, PowerMill has the ability to simulate using a virtual stock and machine. Now, this allows you to embed your virtual machine's capabilities in the digital environment, letting you verify entire projects for collisions or near misses and identify problems early in the process. You then have the option to use alternative tooling or use 5-axis tilting to avoid collisions. This improved program safety can inspire confidence, confirm your part can be machined before it is sent to production, helping to avoid unplanned machine downtime. So how can Fusion 360 help in this situation? Well, in this case, accurate fixture models in PowerMill are vital for accurate simulation. So we look to Fusion 360 to help do this. Fusion 360 has ANYCAD, which allows it to open any native CAD files from other modeling systems. This allows the model to be combined into Fusion 360 assemblies, where the link to the original CAD model is still maintained. Parts can then be analysed for fit and function. Fusion 360 brings design teams together, letting you manage the design process and collaborate with your team, clients, and partners. And the distributed design functionality lets you insert one design into multiple designs and maintain the associativity. So in this example, we can see that the original data in this case is from a third-party CAD software. Now we can import the data into Fusion 360, and from there we can create the fixture that we believe we require for machining within PowerMill. So we export the data to PowerMill, where we create our machining features, in this case some simple 2.5D index pockets. We then run through the simulation to verify that all looks good. Now, because we have the full machine environment, we can see that when we tackle the lower pocket, we have a collision with the base of the machine. We can either fix this ourselves, or we can use Fusion Team to communicate with our team members to request a change. In this case, adding a 100mm riser plate to provide a bit more clearance for machining. Again, back in Fusion 360 to add the additional piece of fixturing before sending it back over to PowerMill to rerun our simulation verification process in the full machine environment. Running through, we have the initial roughing operations, then some hole drilling and the top face cleaned up. And then we can start tackling the 3+2 operations. Note you can see when we're machining these areas, we're not getting collisions at the base of the part now, with the final check being the lowest pocket. We can now be satisfied that this part can be run safely. And finally, because ANYCAD uses a direct link to the original CAD files, any update in the third-party CAD data will also be reflected inside Fusion 360. Now, in this next example, we'll look at Fusion 360 with FeatureCAM workflow. Now, in this example, we have a high-value fluid flow component that we wish to machine in FeatureCAM. FeatureCAM makes an ideal choice for this part as it supports multitasking terminal machines that have multiple turrets and spindles. It also has full machine simulation, meaning that we can machine the part with confidence. But for more peace of mind, it pays to have an accurate representation of your tool holders too. Fortunately, FeatureCAM also supports the asymmetric geometry of turning tools, allowing the use of STL and solid models for the holder. So how can Fusion 360 help here? Well, with a comprehensive range of CAD tools, Fusion 360 can be used to either import tool holder models from manufacturers for modification, or build the new tool models required for accurate simulation. Fusion 360 has constraint-based sketching, which can be used to derive model profiles. It has surface, solid, and mesh modeling, as well as parametric, direct, freeform, and assembly modeling, meaning Fusion 360 can be used to create accurate tooling models ready to be used for the toolpath programming and simulation. Once created, models are stored in the cloud and can then be exported in a range of formats suitable for the software that will import them. So in this example, you can see that we have begun programming the part, but want more accurate simulation. We're going to take the curved geometry of the insert and paste an example of it into the FeatureCAM window, which can then be exported as a DXF file to be read into Fusion. Once we have the insert geometry inside Fusion 360, we can extrude this to derive the insert body, and then we can use Fusion 360's powerful CAD tools to build our tool holder accurately. This can then be exported back to FeatureCAM with the solid model selected as the tool holder and used in our machine simulation to build confidence in our programming. Next, we'll look at an example of Fusion 360 with PowerShape. Now, we have spoken a lot about Fusion 360's CAD capabilities, but you might be using PowerShape for your existing CAD modeling requirements. And there are many scenarios where that makes sense. You probably have existing models with solid histories of features, so you can make easy modifications. Or maybe you are using PowerShape's capabilities to perform modeling for manufacture edits, or perhaps even using PowerShape for reverse engineering or re-engineering of parts. So how can Fusion help here? Well, aside from the possible option of manufacturing your PowerShape parts in Fusion 360, one obvious area is where it can help is that of mechanical or thermal simulation. Fusion 360 can provide simulation studies of your PowerShape design models, including static and nonlinear static stress, determine modal frequencies and buckling modes, and event simulation and more. It can be used to determine if our part designs meet our expectations for strength and help us determine which materials we might want to choose when it comes to the manufacture of our parts. So in this example, you can see that we have our PowerShape history model where we have a series of modeling features used to derive the shape of our component. We can send this over to Fusion 360 and perform, in this case, a mechanical linear stress simulation study to verify our part. When performing a simulation, we must enter our structural loads and constraints and material types. In this particular case, we are selecting two different materials, those being aluminium and mild steel. Once all simulation factors are chosen, we can send it to the cloud to be solved. From the results, we can analyze the deformation of the model and investigate displacement stresses and common failure criteria. In this case, we can see our two different material choices, aluminium and mild steel, animated side by side. This can help us determine which is the primary material that we want to select for our parts manufacture. In this example, we will look at Fusion 360 with PowerInspect. Now, as suggested in the previous example, Fusion 360 can be used for manufacturing, and of course there is an overlap between Fusion 360, FeatureCAM and PowerMill when it comes to some aspects of 2.5, 3 and 5 axis milling and turning and turn mill, where FeatureCAM excels in automation and multitasking machine support and can address wire EDM, and PowerMill excels in complex 5-axis machining and robot support. Fusion 360 is a great option for machine shops needing a general range of machining capability. Fusion 360 can therefore be an option for PowerInspect subscribers that want to standardize their software provider for both manufacturing and metrology. And even if metrology is the only focus, Fusion 360's CAD capabilities can still be used by inspectors by building accurate fixtures for CMM simulation and collision checking of CNC probe paths. By utilizing Fusion 360 to model complex fixture assemblies, you can use PowerInspect's strong CAD capabilities to accurately define the measurement environment. This allows you to collision check and avoid the fixture and other components on the CMM to build safe, automated CNC probe measurement sequences to verify parts. From this, you can report on part quality to achieve final approval. We start this example with the part manufacturer in Fusion 360, in this case a turn mill process. We establish the machining operations we require within Fusion 360 before running through a simulation of the part to check the roughing and finishing operations. Once the part is manufactured, our attention turns to its measurement. The part can be placed onto the work holding using our assembly modeling in Fusion 360 by quickly using joints to align the part to our fixture setup. Any additional elements to the setup can be added to finish the full fixture. We can then import it into PowerInspect using the auto position to place it quickly onto the CMM. From there, we can create our automated measurement sequences before running through the simulation on the CMM, verifying we have no collisions with either the fixture or other parts and the probe setup or CMM. We finish with the final check of our report to verify the accuracy of our part. For the final workflow, we will return to Fusion 360 with PowerMill. Now, as mentioned in the introduction, PowerMill is an expert CAM package with a vast library of comprehensive finishing strategies to machine complex parts. This gives you greater choice, flexibility, and efficiency when machining your parts. And the advanced tool axis control with full collision avoidance means complex parts can be readily addressed. So how are Fusion 360 and PowerMill linked here? Well, you may have heard of generative design, and I've mentioned it a couple of times in this presentation, but obviously this is a technology which mimics nature's evolutionary approach to design. Now, it starts with the problem statement to satisfy the design conditions such as functional requirements, material type, manufacturing method, and performance criteria. It then evaluates and presents a number of generated designs that satisfy the requirements with each potential solution containing performance data. Generated solutions can be evaluated in real time, returning to the problem definition to adjust goals and constraints if needed. The design can then be output for minor design modification. Now, with a generative design result, the gains are often in correlation to the complexity of the design, which is as a direct result of the chosen method of manufacture. For example, simpler 2-axis parts may be heavier than 3-axis parts, and 3-axis heavier than 5-axis parts, and so on. So for the most complex results, an expert-level CAM software is required. In this example, we're going to redesign an automotive upright. We start the generative design process by defining the design criteria within Fusion 360, such as the areas we want to preserve and avoid. We then define the loads, method of manufacture, and material types before sending to the cloud to be generated. Once done, we are then presented with all of the possible permutations that satisfy the design criteria we defined. Once we've selected the design that best suits our needs, we can define the machining fixture before passing this all over to be manufactured in PowerMill. Now, PowerMill has the expert capabilities to machine the most complex 5-axis generative designs. With a range of roughing and rest roughing capabilities, the machining of such components is possible. High-speed toolpaths, both in terms of calculation and cut time, help us quickly rough and finish these highly complex components, whether that be simple 2.5-axis, 3-axis, or more complex 5-axis machining. Collision checking and automatic collision avoidance, combined with a full machine simulation environment, inspires confidence that these complex parts can be run first time, increasing your throughput to quickly finish the part successfully. So let's summarize. In this presentation, we've seen how our current product portfolio is laid out today, and we have seen how Fusion 360 is making the next generation workflows available to our subscribers. We have seen a range of workflows which combine Fusion 360 with PowerMill, FeatureCAM, PowerShape and PowerInspect to address fixture and tool holder design, manufacturing and generative design processes.
Thank you for attending my virtual presentation. I will be happy to answer any questions about it that you may have.